Okay, we are again looking to find maxes and mins, relative extrema, for g. We are given a picture instead of an equation for g double prime. So this graph is of the second derivative. They were nice enough to give us critical numbers, which means the first derivative is either 0 or undefined at these points. And specifically, because these are all polynomial functions, there will be no values on the parent or any of its derivatives where we have undefined results. So we know that g prime of negative 2 has to be 0 because it's a critical number and it has to be defined. Same thing at g prime of 12 has to be 0 because it's a critical number and it's not undefined. It's a polynomial function. It's on a polynomial function. G prime of 40, same deal, has to be 0. So we can immediately plug these critical numbers into the second derivative, g double prime at negative 2. Just using the graph, I don't know the height of the second derivative graph at negative 2, but I know it's negative. Oops. Because it's way down below the x-axis. And that tells me that g is concave down when x is negative 2. If the first derivative is 0 there, that means we have a relative min at that point. G prime of 12 is 0. G double prime of 12, if you go to the graph, that's kind of a problem. That equals 0, which means the second derivative test is inconclusive. So we'll come back to that one. G prime of 40 is 0. G double prime of 40, again, it's not specifically on the graph, but we can conclude it is positive because the value is very far above the x-axis. We have a concave up function at that point then. If it's concave up with an extrema on it, it must be a min. Now this whole 12 deal, I'm going to just make a very crude sketch of the g prime graph. I do know that the g prime graph when x is 12 should have a height of 0. So I'm going to plot that. And quite frankly, that's the only thing I really know explicitly about the g prime graph. If I do a little more digging, I could ask myself, now is g prime changing from positive to negative, or from negative to positive, or maybe there's no change at all? That's all I really need to know to answer information about g's extrema. So I'm like, well, I wonder what g prime's derivative is doing around here. Well, heck, g prime's derivative is g double prime. G double prime changes from positive to negative values around x is 12, which means g prime changes from increasing to decreasing slope around x equals 12. So again, g prime's slope changes from increasing to decreasing because its derivative values change from positive to negative. Therefore, there is no sign change in g prime, which means g will not have any extrema at that point. So we can now answer A and B. Where does g have a relative min? At x equals 40. How do I know? Because g prime of 40 is 0, and g double prime of 40 is positive. Where does g have a relative max? At x equals negative 2. How do I know? Because g prime of negative 2 is 0, and g double prime of negative 2 is negative. Why do I keep doing that? And we've got A and B done.